Hi days, NEET exam is very near. You may be afraid of that, what to do, how to do, like that. So don't worry, 1,000 miles of a journey starts with a single step. Here, the brilliant Qatar is going to introduce a line by line videos for you people. If you go through this video, you can attend 50 questions from each chapter, and along with that, from our material you will get 50 questions, and from the mock test you will get 50 questions. Total 150 questions you are going to solve. In NEET exam, we know in chemistry there are 50 questions are there. Out of that, 45 questions only you have to attend. We have 20 chapter including P block elements. Once we are going through this 150 question, I am damn sure about that, you can solve the entire question and you can achieve your dream in the first attempt itself. I hope you guys are ready to blast. So let's start with the line by line question from the chapter Electrochemistry. Let's go. Now we are going to discuss about the important MCQs from the chapter Electrochemistry, especially the line by line questions from the NCERT. This chapter is somewhat, students are feeling like that, somewhat difficulties here and there. Anyhow, let's see. If there are any difficulties is there, don't worry about it. I am here. Okay, we will solve it together. Okay, ready? So, here is the first question, guys. You have to read the question very clearly, very carefully. Okay. In hydrogen oxygen fuel cell, I hope you heard about hydrogen oxygen fuel cell, H2O2 fuel cell. Okay, H2O2 fuel cell, you already learned about it. Okay, so you know the complete reaction, the overall reaction is actually H2 and O2 reacted to give you what? H2O. This is the reaction actually. H2 plus half O2 gives what? To H2O. This is the reaction actually. So here they are asking, the combustion of hydrogen occurs. There, the combustion of hydrogen is reacting with oxygen, occurs for what? To produce high purity water. No. That's actually byproduct. We are getting byproduct. That's actually the outcome. Nothing. That is, the combustion is not occurring to get water. Okay, not for that. Then for what? To create a potential difference between two electrode. One is hydrogen electrode is there. One is oxygen electrode is there. In between them, to create a potential difference, then only we will get what? An EMF, electromotive force, and energy we will get. So, to create potential difference between two electrodes only, that combustion occurs. Because of that only that combustion occurs. So, answer is what? B is the correct answer. I hope you guys got it. If it's so, then we can move to the next question, guys. This is the next question. What's the question? Fluorine is a best oxidizing agent because it has. You learned the reactivity series, or else you learned the electrochemical series. There you learned fluorine is the powerful oxidizing agent and lithium is the powerful reducing agent. They are asking why it's so. Why fluorine is most powerful oxidizing agent? The idea is simple. What's the idea? We arranged them in the increasing order of reduction potential. So, if reduction potential, especially standard reduction potential, instead of standard reduction potential, I am using SRP. If SRP is more, okay, standard reduction potential is more, meaning easy to reduce. Standard reduction potential means tendency to reduce. That reduction tendency will be more, meaning the one which undergo reduction can act as oxidizing agent. So what is the thing they are asking? If it acts as an oxidizing agent means it's SRP. Standard reduction potential should be very high. So that means this is the highest. E0 red means standard reduction potential. So option B is the correct answer. If they are asking about the best reducing agent means its standard reduction potential should be low, or else its oxidation potential should be high. That's the idea. I hope you guys got it. Okay. Then if it's so, then we can move to the next question, guys. This is the next question. What's the question? E0 for the half cell. Zinc 2 plus bar, zinc is minus 0.76. Okay. Then they are asking EMF of the cell, zinc bar, zinc 2 plus in 1 molar. double slash 2H plus 1 molar H2 1 atm is. So here they are giving, you know the ideas and all, zinc bar zinc 2 plus, okay, zinc bar zinc 2 plus. I hope you are listening properly. Is it so? Yeah. 1 molar, okay, then double slash represent the salt bridge. Then after that again 2H plus, okay, 2H plus, that become what? H2. This H2 is in 1 atm and this one is in 1 molar. So this actually what? She. 1 molar 1 atm means she. Standard hydrogen electrode only this one. And this is zinc bar zinc 2 plus. They are asking about EMF of the cell. What's the formula to find out EMF of the cell? EMF of the cell is E0 cell. E0 cell equal to what's the formula? What's the formula we can use? E0 cathode minus E0 anode. E0 cathode minus what? E0 anode. So we know that we must have to understand that the one which is in left hand side should be the anode. The one which is in right hand side should be the cathode. This will be the cathode. So anode is zinc, cathode is hydrogen. So we can write the answers. We can write the value. What is E0 cathode? Cathode is hydrogen. So for she, what's the E0 value? 0. That we know. Minus E0 anode. Its anode zinc bar zinc 2 plus value they already given. What's the value? Minus 0.76. So minus 0.76. So 0 minus 0.76 equal to plus 0.76. So option is B is the correct answer. I hope you guys already got it. So no need to do this one because we know this is minus 0.76 and she given means the answer is positive. You have to take the positive value. That's the answer. That's it. Okay. If it's so, then we can go to the next question, guys. This is the next question. What's the question? The electrolyte used in Leclanché cell or dry cell. We know in Leclanché cell or dry cell, the anode is zinc rod. Anode is zinc rod. That idea we know. Zinc rod we are using as what? Anode. And cathode we are using is graphite. Graphite is used as what? Cathode. Okay. And the electrolyte we are using is actually a paste of ammonium chloride, NH4Cl, okay, NH4Cl and ZnCl2, along with we are using what also? Manganese dioxide also we are using. So answer is what? Moist paste of ammonium chloride and zinc chloride is used as the electrolyte. That's also direct question. We know that we are doing NCERT lane by lane. What are the ideas you learned there? That only we are making it as a questions. Okay. I hope you can got it. You got the idea clearly. Ready? Yes. If it's so, then we can go to the next question, guys. This is the question. What's the question? They gave assertion as well as reason type question. This assertion reason question type comes means you have to be more careful because students usually used to make problems here. Okay, many difficulties may be there. You may be many twists may be there. You have to be more focused about that. Okay, don't get worried. Okay. So don't get be panic also. Okay, I'm here. We will do it. Okay. So what's the assertion? Ag plus bar Ag. That means this is actually the reduction potential. Ag plus become Ag. That's reduction potential. Increases with the increase in concentration of Ag plus ion. We know actually from Nernst idea, we know Nernst already given one equation. I hope you remember for a single electrode, Ag plus 1 electron gives Ag. For this electrode reaction, we know the Nernst equation. How to write? Ag plus. I hope you are following me. Ag plus bar Ag equal to E0 Ag plus bar Ag, okay, minus 0.0591 by n, okay, minus 0.0591 by n log
log 1 by concentration of Ag plus. This at 298 Kelvin. Okay, if it is not 298 Kelvin means here we can take 2.03 RT by NF we can take. Here N value is 1. N value is 1. So no need to think about that. This much portion, this portion before the logarithm, that portion is constant. Okay, you don't want to look about that. You don't want to worry about that. And also one more thing, one more idea you have to remember. Listen to me very clearly, very carefully, guys. So this one also, this portion also, this E0 value also constant. E0 Ag plus bar Ag also constant. Standard reduction potential only, that also constant. And this one also constant. This one also constant. So you have to think about this one. You have to think about this area, the last area, this one, here this area, log 1 by Ag plus, that area you have to think about. Now you can look here, whenever concentration of Ag plus increases, concentration of Ag plus increases, this Ag plus increases means 1 by Ag plus decreases. Ag plus increases means 1 by Ag plus decreases, automatically logarithm of that value, logarithm of 1 by Ag plus, that will decrease, because 1 by Ag plus is decreasing means log 1 by Ag plus also will be happening what? Decreases. So from E0 we are subtracting a small number value means E Ag plus bar Ag increases, because it's a small value that we are subtracting from this value means that will be also increases. So the thing is that E Ag plus bar Ag increases with the increase in concentration of Ag plus ion. That statement is correct. That statement is correct. And reason, E Ag plus bar Ag has a positive value. That also correct. That also correct. That also positive value only, not negative value. That E Ag plus bar Ag has a positive value. That also correct. That's also correct, because we know that E0 Ag plus bar Ag is positive. From that we are subtracting a positive number, we will get a positive value only. Okay, that value will be less. So automatically we will get a positive number only. Both are correct, but not the correct explanation. Not the correct explanation. So both A and R are true. R is not the correct explanation of A. So option B is the correct answer. Option B is the correct answer. I hope you guys are following me very clearly and carefully. Is it so? Okay, then if it's so, then we can go to the next question, guys. This is the next question. What's the question? Hydrogen electrode is placed in the solution where pH is 10. Okay, they given pH is 10. pH value is 10. pH equal to 10. Okay, you are keeping an electrode in a solution. You are keeping an hydrogen electrode is placed in the solution of pH 10. Okay, and the potential of this electrode will be, you have to remember one formula. I am going to teach you one easy formula. The potential of that electrode. So that is hydrogen electrode, EH plus bar H2, EH plus bar H2. Okay, EH plus bar H2 will be, you can use the formula, you have to remember the formula, minus 0.0591 pH. This is the formula you have to use. If we are keeping an hydrogen electrode in a different pH solution, we have to use the formula what? We have to use the formula EH plus bar H2 equal to minus 0.0591 pH. That's the formula you have to use. Okay, you have to use. Okay, ready? Then now what's the value? What's the value? What's the value of pH they given? What's the value of pH they given, guys? pH value is 10. Now you can find out easily. You can find out minus 0.0591 into 10, meaning minus 0.591. What's the value? Minus 0.591 volt. Option B is the correct answer. If you know the formula means this idea is easy. And also you have to remember this is a reduction potential only. H plus become H2 means reduction potential only. Reduction potential value only we are calculating. That is minus 0.0591 pH. Okay, don't forget. Is it okay? Then if it's so, then we can move to the next question, guys. This is the next question. What's the question? Come on everybody. For a reaction, A solid plus 2B plus gives A2 plus 2B solid. Kc has been found to be, equilibrium constant is given. Kc is given. What's the Kc value? 10 raised to 12. 10 raised to 12. Okay, and the E0 cell value. What's the formula for finding E0 cell? We know E0 cell. This is at 298 Kelvin. Okay, don't forget this is at, if they are not giving also you have to remember 298 Kelvin. So E0 cell equal to, the formula is 0.0591 by N. N into log Kc. Into log Kc. What's the value of N, guys? What's the value of N here, guys? You can see that, listen to me very carefully. Okay, you can see that here this A become A2 plus, meaning how many electrons are participating? 2 electrons. Similarly, 2B plus become 2B. There also how many electrons are participating? 2 electrons. So total how many electrons are participating? 2. So that's why this N value is equal to how much? N value equal to 2. Now we can substitute the values. Guys. Now we can substitute the values like this is equal to 0.0591 by 2. Okay. Into log Kc. What is log Kc? Log Kc equal to Kc they given 10 raised to 12. 10 raised to 12. Now we can apply the property of logarithm. What's the property of logarithm? Log 10 raised to 12 how much? Log 10 raised to 12 how much? 12 into log 10. What is log 10? Log 10 is 1. So answer is 12 there. So instead of log 10 raised to 12, what I can write? 12. So 0.0591 by 2 into 12 will come. 0.0591 by 2 into 12 will come. I can cancel 2 and 12. So that will be equal to, here 6 will be there, 0.0591 into 6 will come. 0.0591 into 6. So option will be A, 0.354 volt will come. 0.354 volt will come. So option A is the correct answer. So nothing to think, nothing to worry. This kind of questions they usually used to ask in many NEET examination. They usually used to ask. So don't forget about the formula. E0 cell equal to 0.0591 by N log Kc. That formula you have to remember, guys. I hope you will remember it. Ready? If it's so, then we can go to the next question. This is the next question. What's the question, guys? What's the question? The order of equivalent conductance at infinite dilution of lithium chloride, NaCl, KCl. Wow, it's a simple and humble. Okay, so lithium chloride is there, then sodium chloride is there, then KCl is there. And while we are considering, this is lithium plus Cl minus, Na plus Cl minus, K plus Cl minus. Is it so? Then one more idea you can note down from there. That is what? That's what? Here is Cl minus, here also Cl minus, here also Cl minus. Anion is same. So that's why we don't want to bother about anion, because anions are same. If they are same means no need to bother about it. There is no difference in anion. So the main problem is because of what? Cation. So which all are the cation available here, guys? Which all are the cation available here? So lithium plus as well as Na plus as well as what? K plus. So these are the cation. Now we can think. Now we can look the question. What's the question? They are asking about equivalent conductance at infinity dilution. Equivalent conductance depends on the ability of the movement of ions. What? Ability of the movement of ions. If the ability of the ions, if the ability to move is more, means this equivalent conductance also will be more. Equivalent conductance or molar conductance. Equivalent conductance in terms of normality, molar conductance in terms of what? Molarity. Both will increases. Okay, both will increases with mobility. So we have to look which one will move more. Lithium plus is there, Na plus is there, K plus. We may think like that, yeah, smaller the cation. This is the smaller the cation, movement will be more. But the problem is that here they are telling infinity dilution, meaning much more water you are adding. You are adding water. So the thing is that the hydration enthalpy of lithium plus is much more. Meaning this lithium plus have high tendency to get hydrated with water. That means more water molecule will come and bind with lithium plus. More water molecule will come and bind with what? This lithium plus. More water molecule will come and bind with what? This lithium plus. Okay, this lithium plus, more water molecule will come and bind. Meaning this lithium plus become bulky, bigger one. Automatically its movement will be slower. What about K plus? Its size is bigger. Automatically the water molecule get attached is less. So hydrogen enthalpy is less. So meaning it can move more faster. So what's the answer? KCl will be having more equivalent conductance than NaCl than lithium chloride. So what's the option? KCl will be having more equivalent conductance than NaCl than lithium chloride. So option B is the correct answer. I hope you guys got it. So you have to remember equivalent conductance directly inversely proportional to the radius or the size of the cation. You don't think like that. Here the size of the cation is smaller, here lithium plus. The thing is that at infinite dilution, water molecule will get attached with the lithium plus and it become bulkier one. Okay. If it's so, then we can go to the next question, guys. This is the next question. The reference electrode is made by using. We are using primary reference electrode is standard hydrogen electrode. But the problem is that in the case of standard hydrogen electrode, to keep that 1 atm, some gas we are keeping, that is difficult and all. So that's why we are using a secondary reference electrode. One of the secondary reference electrode is calomel electrode. In calomel electrode, we are using what? Calomel electrode is Hg2Cl2. That is calomel. Okay, Hg2Cl2. So the secondary reference electrode is what? Calomel electrode. That idea you have to remember. Not copper sulfate, not HgCl2, not ZnCl2. This is called calomel. Okay, calomel electrode. Don't forget the idea. You have to remember it. Okay. If it's so, then we can go to the next question, guys. This is the next question. What's the question? Which one of the following is a strong electrolyte? So strong electrolyte is formed from either it may be strong acid or strong base, or it is a salt formed from strong acid and strong base. That's the idea. So here while you are looking about HCN is a weak acid. It is a weak acid only. This one is a weak acid. So weak electrolyte. Okay. NH4OH. That also what? NH4OH also what? That's also a weak base. Weak base. Okay. That's a weak base. Weak base. Weak base only. What about this one? H2SO3. H2SO3 also weak acid. H2SO4 is a strong acid. H2SO3 is a weak acid. What about CaNO3 twice? Calcium nitrate. Calcium nitrate. Okay. CaNO3 twice. This is actually formed from where? CaNO3 twice is formed from calcium hydroxide. Calcium is actually S block element, second group element forming hydroxides are highly most acidic. So this is strong, sorry, most acidic, not strong acidic, most acidic, strong basic. I'm really sorry, most basic. Okay, alkaline earth metals, alkali metals. That's why they are basic. Strong basic, calcium hydroxide is strong basic, and NO3 we are obtaining from HNO3. This HNO3 is strong acid. So it is a salt of strong base and strong acid. Automatically it is a strong electrolyte. So option A is the correct answer. I hope you guys got it. Ready? So here is the next question, guys. Which of the following decrease on dilution of electrolyte solution? Okay, this idea you know very well. Which of the following decrease, listen to me very carefully, guys. Listen to me very carefully. Decrease on dilution of electrolyte solution. Okay. So you are diluting the electrolyte. Which one of the following will decrease? We know while we are diluting, the number of ions per unit volume will decrease automatically. Specific conductance or specific conductivity will decrease. Specific conductance or specific conductivity will decrease. So option C is the correct answer. While we are diluting or decreasing the concentration, okay, dilution increases or decreasing the concentration, equivalent conductance as well as molar conductance will increases. Here specific conductance will what? Decreases, because number of ions per unit volume decreases. Number of ions per unit volume decreases automatically. During dilution, this value will decreases. That's it. I hope you know. This is a simple idea, simple concept, direct concept only, right? Okay, if it's so, then we can move to the next question. This is the next question. This is the easy question. The variation of equivalent conductance of a strong electrolyte with the concentration is correctly shown in which of the following figure? The variation of equivalent conductance or molar conductance. Equivalent conductance or molar conductance of strong electrolyte. We know the equation. What's the equation? that is d by Huckel-Onsager equation. You remember the equation lambda m infinity, that equation you remember, lambda m c equal to minus b root c plus lambda m infinity. This lambda m c means molar conductivity at any concentration c, and b is a constant and c is the concentration, and lambda m infinity is the limiting molar conductivity. Here they are asking about what? Equivalent conductance. So instead of m, what we can write? EQ, equivalent. So molar means molarity, equivalent means normality. No, nothing big difference. Okay. So here instead of lambda m c, we can write what? Lambda EQ C. Okay, that's equal to minus b root c plus lambda EQ infinity. That's it. So this is of the form of, it's a straight line, y equal to mx plus c. Y equal to what? Mx plus c. That formula, that's a straight line. That's having slope negative. So which is the equation actually? We need a graph between lambda and root c. And the slope is negative. So the option B is the correct answer. Which is the correct answer? B is the correct answer. For which electrolyte? Strong electrolyte. So while we are extrapolating this graph will touch this point y-axis. That is called lambda EQ infinity. I hope you guys got the idea. So option B is the correct answer. And this one, this D represent for weak electrolyte only, that represent. Okay, that you know, I hope so. If it's so, then we can move to the next question. This is the next question. What's the question? The quantity of charge required to obtain 1 mole of aluminium from Al2O3 is. What about the idea? Simple. Al2O3. How we can write? Al2O3 is how we can write, guys. Al2O3 will dissociate as 2Al3 plus 3O2 minus. Okay, 3O2 minus. We need to get what? 1 mole of aluminium. 1 mole aluminium we need to obtain. So here in Al2O3, how many Al3 plus are there? 2 Al3 plus are there. 2 Al3. So if we need Al3 plus, 1 Al3 plus means from 1 Al3 plus we need to get 1 aluminium, means we need 3 electron. If I am using 1 mole Al3 plus means I need to get 3 mole electron I want to use to absorb, for the reduction. So that means 3 mole electron means 3 farad. 3 farad charge is required for to get 1 mole aluminium. If it is 2 aluminium means here it will be 6 mole electron, 6 farad, and here it will be 2 mole aluminium I will get. So they are asking about to obtain 1 mole of aluminium from Al2O3. So that means 1 mole aluminium means 3 mole. That's it. Okay, that's the idea. So 3 mole means 3 farad. Option C is the correct answer. I hope you got it. Easy, right? Okay. Then we can go to the next question. This is the question. This is a very humble question. Okay. Electrolysis of H2SO4. Concentrated. What? Concentrated H2SO4. Concentrated H2SO4 means you must have to remember that contain H plus as well as what? HSO4 minus. H plus as well as what? HSO4 minus will be there. Concentrated means at positive electrode, towards positive electrode, which one will move? This HSO4 minus will move. Which one will move? This HSO4 minus will move. That will lose 1 electron and it will become what? HSO4. Is it okay? That will lose 1 electron and it will become HSO4 at positive electrode. And if I am taking 2 HSO4 minus means I can write 2 HSO4 minus, that will lose 2 electron. I will get 2 HSO4. This 2 HSO4 is nothing, that is called H2S2O8. H2S2O8. So here oxidation is taking place. Electrode is called anode. Where? Because losing of electron is called oxidation. Oxidation taking place, electrode is called what? Anode. So at anode what I am getting? H2S2O8. So H2S2O8 is the answer. At negative electrode which is going, at a negative electrode this H plus will go, then H plus will gain 1 electron, that is reduction, and it will become H. 2H 2H, 1H plus another H, that will form what? Hydrogen. So hydrogen gas is liberated at a negative electrode. Negative electrode, reduction is taking place. Reduction means what? Cathode. What? Cathode. That's the cathode. That's the cathode. This is the anode. Okay, this is the cathode. This is the anode. So at anode, H2S2O it is getting. So this is the idea about concentrated. If it is a dilute means that won't be H plus as well as H plus as well as SO4 2 minus and H plus and OH minus. From water OH minus will be forming. Okay, so that time we will get oxygen here. That idea you already learned. Anyhow, this is the answer for this question. Hope you guys got it. Ready? If it's so, then we can move to the next question. This is the question, guys. What's the question? What's the question? Here is the question. Using the data given below, find out the strong oxidizing agent. Without looking that itself, we can tell the answer because potassium permanganate is the strong oxidizing agent you are learning. Okay, so answer potassium permanganate MnO4 minus is the answer. Okay, but you maybe think like that, how its source are, why its source are like that means very simple idea we can use. Oxidizing agent, strong oxidizing agent means I already told you in the previous question, oxidizing agent means their SRP value should be very high. SRP value should be very high. Standard reduction potential value should be very high. Now you look about the values. What about the values here? Here Cl2O7. This is not Cl2O7, Cr2O7. Cr2O7 2 minus becomes Cr3 plus 1.33 volt. Okay. And here it becomes Cl2 becomes Cl minus. Its value is 1.36 volt. And here it is MnO4 minus become Mn2 plus 1.51 volt. Cr3 plus becomes Cr minus 0.74 volt. Here everything is reduction because Cr2O7 2 minus Cr3 plus means there also here it is plus 6 become plus 3 reduction is taking place. And here also 0 become minus 1 reduction taking place. Here also plus 7 become 2 plus reduction takes place. 3 plus become 0, that also reduction takes place. So out of this, so every given value is SRP, reduction potential. Out of this, which value is bigger? This value only bigger, 1.51 volt only bigger value. Automatically, MnO4 minus can act as the strongest oxidizing agent. That's the idea. Simple, humble. I hope you guys got it. Ready? If it's so, then we can go to the next question. Before that, I have to ask you one more question. And after that, which is the best? I mean, first one is MnO4 minus. Then less than that, which one is coming after less than that? 1.36 chlorine will come. Like that idea you have to remember. Then after that, which one will come? Potassium dichromate, Cr2O7 2 minus will come. That idea you have to remember. Is it so? If it's so, ready now? Okay, then we can go to the next question, guys. This is the next question. What's the question? E0 for the cell. Zinc bar zinc 2 plus aqua, copper 2 plus bar copper is 1.1 volt. This is Daniel cell. Nothing more than the Daniel cell. I hope you guys know it. Correct? Yeah, I can see the flame. Okay. At 25 degrees Celsius. The equilibrium constant for the cell reaction is, this is the cell reaction. Zinc plus copper 2 plus reversibly gives copper plus zinc 2 plus is the order of. What is this? It's actually Daniel cell. What's the formula for relationship between E0 cell as well as Kc? We know. What's the formula? E0 cell equal to, that we already discussed. E0 cell equal to at 298 Kelvin, what I can write? 0.0591 by N. N log Kc. Here how many electrons they are participating? How many electrons are participating here? Copper 2 plus become copper 2. Zinc becomes zinc 2 plus. They are also 2. So N value is how much? N value is 2. So we can substitute the value. Very easily we can substitute the value. 0.0591 by 2. Okay, 0.0591 by 2 log Kc. Log Kc equal to, what's the value? E0 cell they given. That is 1.1 volt. 1.1 volt. 1.1. Okay, ready? Then what is Kc only they are asking. I can take this one to here. So that will be become what? 2.2 divided by 0.0591. 2.2 divided by 0.0591 equal to log Kc. Equal to what? Log Kc. Equal to log Kc. Now what I want to do? I want to divide it. 2.2 divided by 0.591. I have to divide it. Okay. Listen to me carefully, guys. Listen to me carefully. So what I am going to do? I am going to divide it. Listen, I will write this one like what? This one like what? 22. 22 into 10 raised to minus 1. Is it okay? And this one I am taking like what? 59 point something. That's I am taking as what? 0.06 I am taking. Okay, what? 0.06. 0.06 means 6 into 10 raised to what? 10 raised to minus 1. That also I am writing 6 into 10 raised to minus 1. Here is minus 1 get cancelled. 22 by 6 equal to log Kc. Equal to log Kc. Okay. What is 22 by 6? I can calculate 22 by 6. 22 by 6. Okay. 22 by 6. This one 0.06 will come. I am sorry. 0.06 means 10 raised to minus 2 will be there. So 10 will go to top. Here 10 will be there. Okay. That idea you have to remember. So 22 by 6 means 3 6 are 18. So 18 will come. Then again 4 will come. 40. 40 will come. Out of 40, how many 6 are there? Again 6. 6 6 are 36 are there. So 36. I mean 3.6 will come. 3.6 into 10 equal to log Kc. Meaning that is actually 36. Okay. 36 equal to log Kc. Then what is Kc? Kc, what is Kc? Kc equal to anti-log of 36. Anti-log of 36. Anti-log of 36 means what? 10 raised to 36. I mean 10 raised to 36. That range should come. Okay. I just actually what? Just round it off. That's why only 10 raised to 36. So nearby answer which one will come? That will be the answer. Now we can check the options. Which is option given that here the correct exact option is actually here 10 raised to minus 37 is there, 10 raised to 37 is there, 10 raised to minus 17 is there. So option 10 raised to 37 is the answer. Option B is the correct answer. I hope you guys got it. Ready? If it's so, then we can go to the next question, guys. Next question. This is the next question. What's the question? I hope all of you are enjoying, all of you are watching with that much energy and fire. Is it so? Yeah, I can see the flame in your eyes. Okay. Yes. When dilute HNO3 is electrolyzed, what you will get at anode, what you will get at cathode. That's the idea. So dilute HNO3 means that in HNO3, which all are the ions are there? H plus is there, NO3 minus is there. Okay. H plus is there, NO3 minus is there. Dilute means water also there. H plus is there, OH minus is there. I am writing simply the ions, which all are the ions present in that solution. Okay, that's it, nothing more. So towards positive electrode, which all are the ions will move? NO3 minus as well as NO3 minus will flow, as well as OH minus also will be attracted towards the positive electrode. At the positive electrode, what will happen? That electron will be removed. De-electronization will take place. So which one will have? This NO3 minus have high discharge potential. So the tendency to de-electronization is less. Discharge potential more means discharging is less. That's the idea. So OH minus will discharge. OH minus will discharge means that will lose one electron and it will be become what? OH. It will be become OH. 4 OH will combine. Likewise 4 OH will combine together. This is OH. I'm making it simple. Okay, nothing more. 4 OH. If I am writing means that 4 OH will combine together to give you what? This is one H2O. This is another H2O. So 2 H2O and O2. So 2 H2O plus what you will get? Oxygen you will get. So at a positive electrode, what is taking place? Losing of electron. Losing of electron is called what? Losing of electron is called oxidation. So oxidation takes place at which electrode? Takes place at which electrode? Anode. So at anode, what you are getting? Oxygen is getting. Is there any option like that? Yes. At anode, oxygen is formed. So option B is the correct answer. What about NO2 is formed at anode? Wrong. N2 is formed at anode? Wrong. H2 is formed at anode? Wrong. That is wrong. What about the, I will write the remaining also I am writing. What about negative electrode, which is moving toward negative electrode? H plus. What this H plus will do? H plus will gain one electron and it will be become what? H. And likewise 2H will combine together to give you what? H2. So H2 gas will be evolved at a negative electrode. There gaining of electron takes place. What do you mean by gaining of electron? Gaining of electron is called reduction. Reduction takes place at the cathode. So at the cathode you are getting hydrogen. At anode you are getting oxygen. So option B is the correct answer. My students are getting the idea very clearly. I know that. I think my explanation is very clear. I hope so. Ready? Okay. If it's so, then we can go to the next question. This is the next question, guys. Listen to me very carefully. Listen to me very carefully. What's the question? The equivalent conductivity of a solution of containing 2.54 gram copper sulfate per liter is 91 ohm inverse centimeter square equivalent inverse. Its conductivity would be, that's the question. So they are telling the equivalent conductivity, lambda EQ they given, what's the lambda EQ they given? 91 ohm inverse centimeter square equivalent inverse. Okay, that value they given, lambda EQ they given, and the of given mass of copper sulfate also they given, WB also they given. What is WB? WB equal to 2.54 gram also they given, 2.54 gram also they given per liter. Okay, per liter means the volume in milliliter, we can write it is 1000 ml. So 1 liter means, per liter means 1000 ml. Okay, that idea also they given. Then they are asking about the conductivity. What is conductivity? Kappa only they are asking, kappa. So how we can relate lambda EQ and kappa? That formula we know. What's the formula? Lambda EQ equal to kappa into 1000 divided by n. If it is molar conductance means lambda m equal to kappa into 1000 divided by m will come. What will come? M will come. Here it is normality. So lambda EQ we know and n we don't know. We have to find out kappa. What's the formula for kappa then? Kappa equal to lambda EQ into n divided by 1000. This is the formula. Okay, this is the formula kappa. So here lambda EQ we know. We don't know what is normality. So we can find out normality. What's the formula for finding normality? What's the formula for finding normality? Listen to me carefully. Listen to me carefully, guys. Listen to me very carefully. I am going to calculate the normality. Normality equal to, the formula is normality equal to, we must have to remember, that is n factor into molarity. N factor into molarity. N factor we know. Okay. So n factor into molarity. What's the n factor for copper sulfate? Copper sulfate will be ionized as copper 2 plus SO4 2 minus. So it's charge on, total charge on cation or total charge on anion, that is called n factor. So what's the total charge on cation? 2, or total charge on anion, that also 2, charge only, no need of that negative positive value only we need. Okay, so n value is equal to 2. What's the formula for molarity? Molarity we know. How we will write molarity? Molarity equal to WB by MB into 1000 divided by what? VML. This is the formula. Is it okay? Then we can substitute the value 2 into, what is WB? WB they given 2.54 divided by molar mass. Molar mass how much? 159 point approximately 6, 159.6 into 1000 divided by volume in milliliter, that also how much they given? 1000. So we can cancel 1000 we can cancel. Then here normality we will get 2 into 2.54 divided by 159.6. That value we can substitute here. What we will get? Listen to me very carefully. I hope you guys are following. Kappa equal to lambda EQ value they already gave. What's the lambda EQ value? Lambda EQ value they already gave 91. What's the value? 91. So we can substitute what? Kappa equal to 91 into, listen to me very carefully guys, 91 into, what is normality? Normality is 2 into 2.54 divided by 159.6, and also there is 1000 is there into 1000. While you are solving this one, you can see the options. Listen to me very carefully. While you are solving this one, you will get the answer 2.9 into 10 raised to minus 3. Option A is the correct answer. I hope you guys got it. Okay, yes. Then we can go to the next question. This is the next question, guys. What's the question? Prevention of corrosion of iron by zinc coating is called. We know iron is prevented by what? We are coating, irons are easily corroded. That corrosion we can eliminate it by protecting that one with a highly electropositive metal like zinc. That is called what? Galvanization. That's called what? Galvanization or sacrification, because instead of iron, zinc is going to sacrifice, zinc is going to react and it will undergo corrosion. So that's why it is called what? That especially zinc coating is called what? Galvanization. I hope you know that. Is it so? Okay, then we can go to the next question, guys. This is the next question. What's the question? Which one of the following is not an anodic reaction? At anode, you have to remember anox. At anode, oxidation. At cathode, red cat. You have to remember red cat and anox. Anox means at anode, oxidation. At cathode, reduction. Okay, if you remember two things means you can easily do it. Okay, anox. Wherever oxidation takes place, that is called anode. Wherever reduction takes place, that is called what? Cathode. That's called cathode. So, at anode, what is taking place? Oxidation. Oxidation means loss of electron. They are asking about which is not an anodic reaction. Here what is happening? Here Ag gives Ag minus electron. That electron will come to first Ag plus electron. That is reduction. So option A is the correct answer. What about here? Cu becomes Cu2 plus 2 electrons. Cu is losing 2 electrons. That is anodic reaction, oxidation. What about here? Fe2 plus become Fe3 plus. Here Fe undergo oxidation and losing electron. That's also oxidation. Here also they are losing electron. So losing electron means oxidation. So except that one is A. So A is the correct answer, which is not an anodic reaction. Is it okay? Ready? Okay. Then we can go to the next question, guys. This is the next question. What's the question? When 0.1 mole MnO4 2 minus is oxidized, the quantity of electricity required to completely oxidize MnO4 2 minus to MnO4 minus is nothing to think. Very easy. What about the idea? You are having MnO4 minus, MnO4 2 minus you are having. MnO4 2 minus is permanganate ion. That you are oxidizing it into, sorry, this is manganate ion. That you are oxidizing it into permanganate ion, MnO4 minus. This is manganate ion. Okay, manganate ion. This is permanganate ion. Okay, this is permanganate ion. This is manganate ion. So what's the oxidation state of manganese in manganate ion? You know that. You know how to calculate, and you know that I am writing +6. And in potassium permanganate is +7. Now we know this +6 become +7. During that time, what they are doing? They are losing one more electron. That's the oxidation actually happening. This MnO4 2 minus, they are losing one more electron, and then only they can become what? +7. That's oxidation. So during that time, how many electrons are participating? 1 electron. If you are taking 1 mole here means we need 1 mole electron. 1 mole what? 1 mole electron we need. If you are taking 1 MnO4 2 minus means 1 electron. If you are taking 1 mole MnO4 2 minus means 1 mole electron we required. Okay, 1 mole electron means that is 1 farad. 1 farad means 96,500 coulomb we required. We required for what? 1 mole MnO4 2 minus. But how much MnO4 2 minus they given to you? They are talking about 0.1 mole. So for 1 mole, listen to me carefully, guys. For 1 mole, 96,500 coulomb. So for 0.1 mole, what will happen? 96,500 into 0.1. That is 9,650. 9,650. 9650. So option C is the correct answer. I hope you guys got it. Ready? If they are asking about 2 mole means you have to multiply 96,500 into 2. Likewise, you have to find out. Is it okay? Yes. I hope you got it. Then if it's so, then we can move to the next question. This is the next question. What's the question, guys? Again, this kind of question we already did it. Again, the another question. They are asking the oxidation potential of hydrogen electrode at pH equal to 1. I taught you one formula. EH plus bar H2 equal to, that I taught you. If you are keeping one hydrogen electrode in some pH solution, it's reduction potential. I already told you, I mentioned that one. That is reduction potential you can find out as by using the formula minus 0.0591 pH. So what's the pH value here? 1. So that is minus 0.0591 into 1. Meaning minus 0.0591. That time option is there, minus 0.0591. Don't use that option, because here they are asking about what? Oxidation potential. This is a reduction potential. This is the reduction potential. So what's the relationship between, what is the oxidation potential? Oxidation potential means you have to write EH2 bar H plus. This is how much? What's the relationship between oxidation potential and reduction potential? Oxidation potential equal to reduction potential, but opposite in sign. If it is negative means its oxidation potential is plus 0.0591. So answer is plus 0.0591. Option A is the correct answer. If you are getting this answer, if you are choosing that negative means your 4 mark will go. Along with one negative will go. So that means total 5 mark will lose. Don't do like that. You have to read the question very carefully. So option A is the correct answer. Ready guys? Okay. I can see your that smile. I can see your that energy. Okay. Yes. Let's go to the next question guys. I hope you are along with me. Okay. So this is the next question guys. What's the question? On the basis of E0 values, strongest oxidizing agent is. So again, strongest oxidizing agent. I told you, if some species is a strongest oxidizing agent means, if a species is strongest oxidizing agent, so that means oxidizing agent means it should have high SRP. SRP should be very high. Its SRP, reduction tendency, should be very high. We can look about the question very carefully. FeCN6 4 minus. Okay, this is FeCN6 4 minus become FeCN6 3 minus. So here the oxidation state of iron is 2 plus. Okay, here the oxidation state of iron is 2 plus, and here the oxidation state of iron is 3 plus. 3 plus. So here 2 plus become 3 plus. So here what is actually happening? Here oxidation is taking place. Here what is actually taking place? Oxidation is taking place. So for oxidation, this is actually the oxidation potential only. Minus 0.35 volt only they given. Similarly, Fe2 plus become Fe3 plus. Simply Fe2 plus become Fe3 plus. This is also oxidation. Its value is minus 0.77 volt. They are asking about the oxidizing agent. Oxidizing agent means we need SRP. So we have to consider the reversible reaction. This reaction we have to consider. So that time this will be become plus. And we have to consider this reaction, reverse reaction. That time this become plus. Now you tell me, the one with the high SRP, which one is bigger value? This 0.77 volt is bigger value. So that is for what? This one, this left hand side one, Fe3 plus. So Fe3 plus will be the high powerful oxidizing agent. So answer is A is the correct answer. I hope you guys got the answer very clearly. Ready?
Okay, dears. Shall we go to the next question? This is the next question. What's the question? Molar conductance at infinity dilutions of NaCl, HCl and CH3COONa are 126.4, 425.9 and 91 Siemens centimeter square mole inverse respectively. They are asking you to find out lambda 0 m for CH3COOH. It is a weak electrolyte. CH3COOH is a weak electrolyte. So they are asking you to find out lambda 0 m of CH3COOH. Okay, you know how to find out. We know a weak electrolyte, limiting molar conductivity we can find out by using limiting molar conductivity of strong electrolyte. Here CH3COO is there. So we can start like this. Here CH3COO is there. So you have to look in the given one, okay, you have to look in the given options. In the given options, is there anything contains CH3CO? Yes. Here CH3CO is there. So that we have to take. Okay, that we have to take like what? We have to take like what? Lambda 0 m of CH3COONa. Okay. But here the unwanted one is that Na we don't want. Okay, that we can subtract later. Okay, last we can subtract. And we need CH3CO. That's why the CH3CO containing one I took first. Then again, I am adding what I need. H also I need. Yeah, is there anything contained H? Yeah, HCl is there. So I can add lambda 0 m of HCl. But here Cl I don't need. And Na I don't need. So that means NaCl I don't need. So that I can subtract. Lambda 0 m of NaCl I can subtract. So that will be the answer. This idea is called Kohlrausch's law. You know, by using Kohlrausch's law only we are adding this one. We are finding the
limiting molar conductivity of weak electrolyte. So what's the limiting molar conductivity of CH3CONA? That value they given how much? 91 plus what is lambda 0 m of HCl? HCl is actually 425.9 and lambda 0 m of NaCl, that is how much? Minus 126.4. So now we have to add it and subtract it. What's the value we are going to get? Let's see. 425.9 plus 91. I am adding 91. So 0.9. Here it is 6 and 11. 516.9 I am getting. I have to subtract that one. I mean 126.4 from here. 126.4. If I am subtracting 9 minus 4, 5 is coming. Here 0. 11 minus 2. 11 minus 2 is 9 is coming. Here 4 minus 1, 3. 390.5 will come. So option D is the correct answer. I hope you guys know this one. It's a direct question, okay? We are doing NCERT line by line. So obviously this kind of question you already seen it, okay? Is it fine? Ready? Okay. Then we can move to the next question, guys. This is the next question. What's the question? The passage of electricity in the Daniell cell. Daniell cell. What is Daniell cell? We are keeping zinc in, zinc electrode in, zinc sulfate solution. Okay, this is zinc in zinc sulfate solution. Okay, and copper in copper sulfate solution. I am keeping copper in copper sulfate solution. Copper in copper sulfate solution, and I am connecting with a voltmeter. And here what is that? Here a salt bridge is there. Okay, this idea you know. And they are asking about electrode connected is. Okay, then they are asking from copper to the current, the electricity, the current will flow from copper to zinc. Zinc in the cell, they are telling in the cell, wrong. From the copper to zinc outside the cell, yes. Actually the electron is flow from zinc to copper only electron is flowing, and the current will flow from copper to zinc outside the cell. So option B is the correct answer. I hope you guys got it. Ready? Yeah. I can see that energy. Okay. So we can move to the next question, guys. This is the next question. What's the question? KCl is used in the salt bridge because here we already told you, this is the Daniell cell. Here in this one, this is salt bridge. In this salt bridge we are using KCl. I mean inert electrolyte only we are using. That is to avoid the accumulation of charge in the anode as well as cathode. So the thing is that what they will do, that the K plus as well as Cl minus should have almost equal number. I mean the transference of equal number. So answer is what? D is the answer. The transference number of K plus and Cl minus ions are almost equal. That's why only they can go and neutralize the deposition, charge deposition. So what's the answer? D is the correct answer. Okay, you remember the functions of salt bridge. Salt bridge neutralize the charge accumulation as well as it avoid the liquid junction potential, it complete the circuit and all things you learned. Okay now, if it's so, then we can go to the next question, guys. This is the next question. What's the question? The cell constant of an electrolytic cell. What is cell constant? L by A. L by A is called cell constant. It remains constant for a cell. It is a constant. It won't change with anything. Okay, so it is a constant, remains constant because L length is constant, area is constant, so it is constant. It won't going to change with anything. So L by A is a constant. Option D is the correct answer. It's easy, I hope. Okay. If it's so, then we can go to the next one. This is the next question. What's the question? The number of electrons delivered at the cathode during the electrolysis of a current 1 ampere in 60 seconds. So they are telling current is I equal to 1 ampere and time equal to 60 seconds. Then we can find out the charge. Charge Q equal to what? IT. Q equal to IT. Okay. Q equal to IT means I equal to 1 into 60. That means 60 coulomb charge is delivered at the cathode. We know the charge of one electron is 1.6 into 10 raised to minus 19 coulomb. Charge of one electron charge is 1.6 into 10 raised to minus 19 coulomb. They are asking this 16 coulomb contain how many electrons? So the number of electrons is equal to we have how much charge? 60 coulomb we have divided by what's the charge of one electron? 1.6 into 10 raised to minus 19. If I divide means I will get the number of electrons. Okay. So that's equal to 60 by, this one I am writing 16 into 10 raised to minus 20. 10 raised to minus 20. I am going to divide that 60 by 16 here. Okay. 60 by 16 here. This one I can cancel. 30 by 13 by 8 I will get. Again I can cancel. 15 by 4 I will get. 15 by 4 means 3.75. 3.75 will come. So the 10 raised to minus 20 will go to top. So that means 3.75 into 10 raised to 20. So option C is the correct answer. If you know if you can understand, if you can remember the formulas, means this kind of question will be easy. You may be seen like that the previous NEET questions and all, they are directly asking question from the NCERT. So this kind of question you can expect. You have to expect in the future also. Okay. Idea is clear, guys? Yeah. Okay. So this is the next question. What's the question, guys? The specific conductance in ohm inverse, centimeter inverse of 4 electrolytes P, Q, R, S are given below. They are giving specific conductance. Specific conductance they are giving. Okay. Specific conductance means what? That is kappa. Kappa they are giving. Specific conductance is kappa they are giving. Okay. For electrolyte they are giving. Then the question is the one that offers highest resistance to the passage of current is. So which one have highest resistance? Resistance means I am representing R. Okay. Which one have high resistance? That's the question. So we know simple idea. What's the idea? We know resistance is equal to rho into L by A. This is the equation, rho into L by A. Resistance equal to rho into L by A. Okay. So they are giving what? Specific conductance only they are giving. Okay. Specific conductance only they are giving. That means kappa only they are giving. Specific conductance means it is actually the reciprocal of this resistivity. Okay. Reciprocal of resistivity. From here we must have to understand. If you want means I will write like this also. I am taking the reciprocal. This is 1 by R. 1 by R. That's equal to 1 by rho. Equal to this one reciprocal is A by L. A by L. So 1 by R means that is nothing. The reciprocal of resistance is conductance G. Conductance G. Reciprocal of resistivity, conductivity or specific conductance kappa. Kappa into A by L. A by L is the reciprocal of cell constant. That is a constant. So we know that when kappa increases, from here we can tell that when kappa increases, G increases. G means conductance increases. Kappa increases, G increases. Automatically, G increases means R decreases. R decreases. Okay. Resistance decreases. From that idea, what's the idea they are asking? They are asking highest resistance. So if resistance is high means G will be less, kappa will be less. So which one will be having low kappa? The one with R. 1 into 10 raised to minus 10 is the smallest number among them. So option C is the correct answer. I hope you guys got it. Ready? If it's so, then we can go to the next question, guys. This is the next question. What's the question? Which of the following is a cathode reaction? This is the reaction. Cathode means which reaction should occur? Reduction should occur. Reduction means decrease in oxidation number or gaining of electron. We can see Fe2 plus become Fe3 plus. Oxidation number is increasing. That is oxidation. That is at anode. Not this one. Option that is wrong. What about 4OH minus gives 2H2O plus O2? Here what is happening here? Here oxygen state is minus 2. Hydrogen is plus 1. Okay. While going to here also hydrogen is plus 1. Oxygen is minus 2. But here it is 0. So there also minus 2 becomes 0. There also oxidation is taking place. So not that one. We have to focus about reduction. What about this one? 2H2O gives 2OH minus plus H2. Oxygen is minus 2. Hydrogen is plus 1. Here also in OH minus also oxygen is minus 2. Hydrogen is plus 1. But here the hydrogen is 0. So what is happening? Hydrogen is reduced its oxidation state plus 1 to 0. So automatically it is the reduction. So this is the answer. What about here? SO4 2 minus sulfur is plus 6. And S2OH 2 minus also sulfur is plus 6. So there is no change. So the answer is cathode reaction is which one? The one which undergo reduction. Reduction is in C. I hope you guys got it. Ready now? Yes or no? Tell me. Yeah. Okay. So this is the next question, guys. This is a very important question. Okay, they asked this question in previous NEET examination. So you have to remember, you must have to remember this question. Okay, if the E0 cell for a given reaction has negative value, okay, they are telling E0 cell for a given reaction is negative. From that itself, you must have to remember that reaction is non-spontaneous. E0 cell negative means that reaction is non-spontaneous. What's the idea you have to remember? Non-spontaneous. What do you mean by non-spontaneous? Delta G0 equal to what? Positive. That's the idea you have to remember. The E0 cell negative means that reaction is not going to occur. Okay. So that means non-spontaneous, delta G0 equal to what? Positive. That idea you must have to remember. Now we can start. Okay. Which of the following give respect to the relationship of the value of delta G0 and K equivalent? What's the relationship between delta G0 and K equivalent? We know delta G0 equal to minus 2.303 RT log K equivalent. If I need to get this delta G0 value positive means this R is always positive, T is always positive, this should be negative. Log K equivalent negative means this K equivalent value should be less than 1. K equivalent value should be less than 1. So K equivalent value is negative. That time this negative and this negative become positive. So delta G become positive and E0 cell become negative. That's the idea. So we can check the options. What about option? Here delta G0 greater than 0. That's correct. That is positive. And K equivalent less than 1. So this is correct only. What about here? Delta 0 greater than 0. K equivalent greater than 1. That is wrong. K equivalent greater than 1 means this will become negative only. So option 1 is the correct answer. I hope you guys got it. Ready now? Is it so? Okay. Then we can go to the next question, guys. This is the next question. What's the question? Cell reaction is spontaneous when? Cell reaction is spontaneous when delta G0 value is negative. It should be negative. Here we already told what E0 cell non-spontaneous means delta 0 is positive. Meaning here in this question they are asking the same thing. Cell reaction is spontaneous at delta 0 is negative. That means during a spontaneous reaction, the Gibbs free energy change should be negative. That means Gibbs free energy should decreases. That Gibbs free energy they are using for some useful work automatically, its energy should decreases. So option A is the correct answer. Okay, ready? If it's so. So this is the next question, guys. What's the question? For a given half cell, Al3 plus 3 electron gives Al. On increasing Al3 plus, the electrode potential. This one we already did in the case of silver. Here also I am writing the same idea. What is the Al3 plus electrode potential of aluminium bar, aluminium 3 plus ion bar aluminium, that's equal to E0 Al3 plus bar Al. Okay, minus I am writing 2.303 RT by NF log 1 by concentration of Al3 plus. This is the equation actually. This is the equation. Here N is equal to how much? N equal to 3. 3 electron participating, N equal to 3. So anyhow this one is a constant. R is constant, T is constant, F is constant, F is Faraday is constant, that also constant. Then what's the idea they are telling? They are telling you are increasing Al3 plus concentration. So whenever you are increasing concentration of Al3 plus, what will happen? That 1 by Al3 plus value will decrease. That will decrease. That decrease means logarithm of that value also will decrease. This value also will decrease. So you are subtracting a value, small value from this one means this will be increasing. So the idea is increases. That increases. Al3 plus bar Al value will increase while you are increasing the concentration of Al3 plus. Idea is okay now? Ready? If it's so, then we can go to the next question. So here the option is A is false and reason is true. So option D. A is, we can write assertion is true. A is false and R is what? R is true. So option D is the correct answer. I hope you guys got it. Okay, there is some problem. So that's why only I wrote what? A is false and R is true is the correct answer. I hope you guys got it. Ready? So again, while we are going to the next question, what's the next question, guys? This is the next question. Which of the following statement is not correct about an inert electrode in a cell? We know that inert electrode, we are using platinum electrode is an inert electrode. Okay, some reactive electrodes are there. If I am using zinc and copper, etc., they are reactive electrode. If I am using platinum, that's an inert electrode. So they are asking about which one of the following statement is not correct. So in inert electrode, it does not participate in the cell reaction. That is correct. That's why only they are called inert. And it provides the surface either for oxidation or reduction. That's also correct. In some cases, it will undergo oxidation. Some cases, it will provide a surface for reduction. Okay. So it provides surface for the conduction of electrons. That also correct. Through that only electron is flowing. What about this one? It provides surface for redox reaction. That is wrong. At a time, it cannot give reduction as well as oxidation. At a time, anyone only possible. Okay. So that's why D is the correct one. D is the not correct means option D is the our answer. Is it okay, guys? Is it okay? Guys, ready? Kalli, I hope you got it. Okay. So this is the next question. What's the next question? This is the question. The standard oxidation potentials for the half cell reactions. Listen to me very carefully. They gave oxidation potential. What they gave? Oxidation potential. Okay. Reactions are the EMF of the cell reaction. For this cell reaction, what is the EMF? What's the formula for EMF? E0 cell equal to E0 cell equal to, I can hear. E0 cathode or else E0 cathode minus E0 anode. Here you must have to remember, here we have to take what only? SRP of cathode minus SRP of anode. Reduction potential only we are taking, not oxidation potential. So what we will do, we have to make it reduction potential. How we can make it reduction potential? We have to reverse the reaction. That time this will be become minus. And here also this one I have to make it reverse. This will be become minus. Now you see which one is the anode, which one is the cathode. Which one is the anode, which one is the cathode. Here you can see Fe2 plus become Fe. It undergo reduction. 2 plus becomes 0. It undergo reduction. So it will be the cathode. So which is the cathode here? Fe is the cathode. What's the value? Not plus, it is minus. Minus 0.41. Then again here one minus is there. That minus I am putting. Then again, what's the anode then? Zinc becomes zinc 2 plus. So anode is minus 0.76. So minus become plus. So I can write 0.76 minus 0.41. So what's the answer? 0.35. 0.35. So is there any option like that? Yes, guys. Option B is the correct one. Of course, you must have to remember that this is not possible. This is not possible. Zero cell value, negative is not possible. Okay. So B plus 0.35 volt is the correct answer. So that idea you have to remember. Okay now. Ready? So then we can go to the next question. This is the question. What's the question? Zinc cannot displace following ions from their aqueous solution. We know the electrochemical series. We know. What's the electrochemical series? We know. Here I am writing lithium. Okay. The one with low SRP. Then I am writing potassium. Then I am writing what? Potassium. You remember, I hope so. Yes or no? Then I am writing calcium. Then sodium. Then magnesium. Okay. Then aluminium. Then zinc. Okay. Then iron. Okay. Then copper. Then silver. Here only I am putting in between copper and iron. I am putting what? Hydrogen. So you learned like that. The one with above, the one with below can displace the above one from there its solution. So zinc can displace iron 2 plus as well as copper and silver etc. They can displace. Okay, hydrogen also they can displace. Here the question is zinc cannot displace which of the following ions from their aqueous solution. You must have to remember silver. Silver is less reactive than zinc because silver on the top, less reactive. And copper is also less reactive than zinc, it can displace. And iron also less reactive than zinc, it can displace iron also. What about sodium? Sodium is downside. Sodium is here only. Sodium is more reactive than zinc. So zinc cannot displace what? Sodium. So option D is the correct answer. I hope you guys got it. Ready? Okay. So this is the next question. What's the question? What will be the EMF for the given cell? What's the cell here? Here the cell is platinum, hydrogen gas is passed through and that become H plus and hydrogen gas again become, hydrogen H plus become P2, H2, okay, platinum. So here the thing is that the electrodes are same but the pressure of the gases are different. This kind of cells are called concentration cells, especially gaseous concentration cells only this one. In that case, you must have to remember the one with low concentration will act or low pressure will act as anode, or else first one is anode. The one with high pressure, that will act as what? That means the one in the right hand side will be act as what? Cathode. This is the idea you have to remember. You have to remember, okay? The one with high pressure will act as anode. The one with low pressure will act as cathode, because high pressure will dissolve. During high pressure, it will dissolve and it will produce what? Ion. Because that means H2 become what? 2H plus. I am writing 2H plus. 2H plus is what? Aqua. Here the pressure is P1. Okay. So that time dissolution will take place. So 2 electron. This is at anode. This at anode. What about cathode? What about at cathode? At cathode, reduction will take place. So cathode means there this H plus, 2H plus will gain 2 electron and it will be become what? H2. It will release. So its pressure should be less. That's the idea. Don't forget the idea. The one with high pressure will act as anode. The one with low pressure will be escape, deposit. Okay, evolve. So that is P2. That is will be act as cathode. So while we are adding, what I will get? This H plus and 2 electron will get cancelled. Only H2 gives what? H2. Here it is P1. Here it is what? P2 will be remaining there. So now what I can do? I can write the reaction. What's the reaction? What's the E cell? What is the E cell? E cell equal to, what's the formula? E0 cell minus RT by NF log, where we used the concentration, here we are using what? Pressure. So pressure of the final one. So that is P2 divided by initial, that is P1. Likewise only we are writing. Here what about E0 cell? Anode is hydrogen, cathode also hydrogen. So E0 cell will be equal to 0 because both are hydrogen only. So their difference is standard. If I am taking, their difference is 0. So for concentration cell, their E0 cell is 0 minus RT by NF. What is NF? NF values, N is here, 2 electrons are there. So 2F, I am writing 2F, 2 electrons are participating, 2F log P2 by P1. So I want to write it in positive terms, means I have to take the reverse. So that will be become RT by 2F log P1 by P2. That time one minus will come out, our minus will be become positive. So RT by 2F into log P1 by P2. RT by 2F into log P1 by P2. So option B is the correct answer. RT by 2F into log to the base. Log means ln. Okay, this is ln only. Base E should be there. Log base E. P1 by P2 will be the correct answer. It will come. Okay. I hope you guys got the answer B. Ready? If it's so, then we can move to the next question. This is the next question, guys. What's the question? Here is the question. How much electric charge is required to oxidize 1 mole of FeO to Fe2O3? You are having 1 mole FeO. 1 mole FeO you are having. You are oxidizing that one into what? Fe2O3. You don't want to think much more. You have to simply, you must have to know about the oxidation state. In FeO, the oxidation state of ion is +2. And in Fe2O3, the oxidation state of ion is +3. So for one FeO to become 1, 3 plus, you need 1 electron. If you are taking 1 mole FeO means you need 1 mole electron. 1 mole electron you required. 1 mole electron means 1 farad. 1 farad equal to 96,500 coulomb. They are asking about 1 mole of FeO. So that means 96,500 coulomb. Option C is the correct answer. Ready guys? Ready now? Okay, if it's so, then we can move to the next question. This is the next question. What's the question? This is the question. Assertion. Lambda m for weak electrolytes show a sharp increase when the electrolytic solution is diluted. We know the graph between lambda m and root C. Lambda m and root C we know. Lambda m versus root C in the case of weak electrolyte while you are diluting, what will happen? Its limiting molar conductivity will sharply increases. It will increases. But in the case of strong electrolyte, it increases like this only. It increases linearly only, like this only. This is for strong electrolyte. This is for weak electrolyte. So that idea is correct. So that is correct. Reason: for weak electrolyte, degree of dissociation increases. That is correct. While you are adding water again, its degree of dissociation increases. So reason also correct. That's the correct. That is because of that only that suddenly it increases. So option A, both A and R is true, and R is the correct explanation of A. Option A is the correct answer. I hope you guys got it. Ready now? Okay. Then this is the next question, guys. Listen to me. Which one is not called a anode reaction? Previously we did cathode reaction. This is anode reaction. Anode means at anode, which reaction should take place, guys? Yeah, I can hear. Yeah. Tell me. Yeah. Okay, that's it. That is at anode oxidation should take place. At anode oxidation should take place. Oxidation means losing of electron. Here, while you are looking Cl minus, that become Cl2. They are also losing of electron. That is correct. Here Cu becomes Cu2 plus 2 electron. That also losing of electron. What about here Hg plus become Hg2 plus 1 electron? That's also losing of electron. What about here? Directly zinc 2 plus, they are gaining 2 electron. So that is the correct one. That is not. Which one is not? That means this is not anodic reaction. This is a cathodic reaction because they are gaining electron. Ready now? If it's so, then we can move to the next question. I know that you are enjoying my session. You can understand whatever I am telling. Ready now? Yes or no? Okay. Here this is the question. What's the question? The unit of equivalent conductivity is equivalent conductivity. That means lambda EQ is. That's the question. Lambda EQ. What's the unit? Lambda EQ equal to kappa into 1000 divided by n. Kappa into 1000 divided by n. Kappa into 1000 divided by n. We have to substitute the values. What about kappa? You know, while doing this one, we can get all the units. Okay, kappa equal to, how I can find out kappa? You know, we already told you resistance. I told you resistance equal to rho into L by A. So we have to take the inverse. So that means 1 by R equal to 1 by rho into A by L. Is it okay now? Ready? A by L. So that means 1 by R equal to G. And this is 1 by rho. That is kappa into A by L. That A by L will come here, means that will become L by A. That means conductance into cell constant is kappa. Conductance, what's the unit? Ohm inverse. So we can write kappa unit. I am writing here. You can see kappa unit I am writing here. Conductance is ohm inverse. Okay, ohm inverse. And here L is centimeter, this is centimeter square. So ohm inverse centimeter raised to minus 1. Okay, ohm inverse centimeter raised to minus 1. That's the unit. So ohm inverse centimeter inverse. That's the unit of kappa. That's the unit of what? Kappa. Then here into 1000 divided by what? Normality. What is the unit of normality, guys? What's the unit of normality? You know, normality equal to, how we will find out? Number of moles, number of mole equivalent. That means given mass divided by equivalent mass into 1000 divided by VML. So given mass is gram. Equivalent mass unit is EQ inverse. Okay, gram EQ inverse. Likewise we can take. Then what is remaining here? V molar. V in milliliter, that means centimeter raised to minus 3 will come. We can substitute this value here. What it will become? Ohm inverse, centimeter inverse. This one gram equivalent inverse into centimeter raised to minus 3. So that means once we are taking this one to top, means what will happen? Here ohm inverse is there. Then this will become centimeter square, and gram equivalent inverse will be there. That will be remaining there. So option B is the correct answer. Ohm inverse centimeter square, gram equivalent inverse. Okay. So this is the question. The unit of equivalent conductivity is. So we know that equivalent conductivity is lambda EQ. Its unit only they are asking. Lambda EQ equal to what? Kappa into 1000 divided by n. Kappa into 1000 divided by n. So we have to find out the unit of kappa. We have to find out the unit of normality. Okay. We know what is kappa. Kappa is specific conductance or specific conductivity. Specific conductivity equal to what? Kappa equal to what? Kappa equal to, we can write, that is equal to G into conductance into cell constant L by A. What's the unit of conductance? This is conductance. Conductance is ohm inverse or else Siemens. Ohm inverse or else Siemens. Okay. Ohm inverse or Siemens. And L by A. L is centimeter. This is centimeter square. So centimeter inverse will come. Centimeter inverse will come. And what about the case of normality? Normality equal to given mass divided by equivalent mass or else number of gram equivalent. Okay. I am writing number of gram equivalent. Number of gram equivalent into divided by volume in liter. Volume in liter. Okay. Not into, divided by volume in liter. What's the unit of number of gram equivalent? Gram equivalent. I mean, like number of moles, likewise only gram equivalent. Okay. For molarity, number of moles. For normality, number of gram equivalent. Gram equivalent is there. That's the unit. Okay. And volume is centimeter cube. That will go to top, means centimeter raised to minus 3. Centimeter raised to minus 3. So now I can substitute the values. What's the unit of kappa? Kappa unit is actually ohm inverse centimeter inverse. Okay. Ohm inverse centimeter inverse. 1000, no unit. And divide by normality, gram equivalent. Gram equivalent and centimeter raised to minus 3. Now I can take this to top, this one to top. So what is remaining? Ohm inverse, gram equivalent comes to top, means gram equivalent inverse, and centimeter raised to minus 3, centimeter raised to minus 1, centimeter square. So ohm inverse centimeter square, gram equivalent inverse. So option B is the correct answer. I hope you guys got the unit. Yes or no? Ready? Okay, that's it. Okay, so this is the next question. This is the next question, guys. What's the question? You have to read the question very clearly, very carefully. Okay, don't forget it. Every time I am telling this one, don't make mistakes. Okay, so this is the question. The molar conductivity of a 0.5 mole per decimeter cube solution. Mole per decimeter cube is nothing, liter. So mole per liter means molarity. So the given thing is molarity. Molarity equal to how much? 0.5 molar. Because why I am taking molar? Mole per decimeter cube. Mole per liter means molarity. Okay. Solution of AgNO3 with the electrolytic conductivity. With the electrolytic conductivity of, they are telling, electrolytic conductivity they are telling. Okay. Electrolytic conductivity means that is nothing, that is kappa. Kappa equal to 5.76 into 10 raised to minus 3 Siemens centimeter inverse. They are asking you to find out molar conductivity is lambda m how much. That is the question. That's the question. How we will find out lambda m? We know the formula. Lambda m equal to, we know the formula. What is lambda m equal to? What we will do? Lambda m equal to kappa into 1000 divided by molarity. So what is kappa? Kappa they given 5.76 into 10 raised to minus 3. Okay. Into 1000. Okay. 1000 divided by molarity. What's the molarity? 0.5. 0.5 will come here. This 10 raised to minus 3 and 1000 we can get cancelled. 0.5 means 1 by 2. That 2 will go to top. So 5.76 into 2 will come. 5.76 into 2 means what? 11.52. 11.52. Option B is the correct answer. What's the correct answer? Option B is the correct answer. 11.52. B is the correct answer. I hope you guys got it. If you know the formulas, this is easy. Like this only for NEET exam also it is going to come. You have to watch the video. You have to watch the sentences very carefully. Okay. So shall we go to the next one, guys? This is the next question. What's the question? They are telling some assertion, some reason. Okay. Every time you are making so many mistakes in assertion, reason. So be careful. Okay. This kind of question your CBSE as well as NEET examination, it is going to come. Okay. So what's the question? Assertion. Copper is less reactive than hydrogen. That is it correct or not? We know the reactivity series. In that, copper is above the hydrogen. So that statement is correct. Copper is what? That statement is correct. Copper is less reactive than hydrogen. That statement is correct. What about reason? E0 Cu2 plus bar Cu is negative. That is wrong. E0 Cu2 plus bar Cu is plus 0.34. That is positive value only. Above hydrogen means it is positive value only. No need to remember the value. Above hydrogen means positive value only it is coming. So that is wrong. So assertion is correct. Reason is wrong. So A is true but R is false. Option C is the correct one. Hope you guys got it. Ready? Okay. So this is the next question. What's the question here? The EMF of the cell. Zinc bar, zinc 2 plus. Its concentration they given 0.1 molar. Double slash, that means salt bridge Fe2 plus. Its concentration they given 0.01 molar Fe. Okay, is 0.2905 volt. The equilibrium constant for the cell reaction is. That's the question. So here you know this zinc bar zinc 2 plus double slash Fe2 plus bar Fe. That is actually what? That is actually a cell. In that cell, we can write the cell reaction. How we can write the cell reaction from there? Here we know this is anode portion. This is anode portion. So from at anode, I will write slowly we can do. Okay. At anode, what will happen? Zinc become zinc 2 plus 2 electron. Okay. Zinc 2 plus 2 electron. This is at anode. What about at cathode? At cathode, what will happen? Listen to me very carefully. At cathode, what will happen? That iron 2 plus will gain 2 electron and it will be become what? Fe. This is the at cathode and at anode. And what will be the cell reaction? I will write the cell reaction here. Cell reaction means I have to add both. While I am adding both, what I will get in left hand side? Zinc plus Fe2 plus gives zinc plus Fe2 plus gives zinc 2 plus Fe. Zinc 2 plus what? Fe. Now I have to write what? Now I have to write its concentration. In the question they given the concentration. What's the concentration of Fe2 plus? Fe2 plus is 0.01. This is 0.01. What about zinc 2 plus? That is 0.1. Don't forget. Okay. Now I can write the equation for E cell. I can write. What is E cell? E cell equal to, you know, E cell equal to E0 cell. Okay. E0 cell minus 0.0591 by n into logarithm of product. What is the product here? Zinc 2 plus. Concentration of zinc 2 plus. Why I am not taking iron? Because it is the solid. It is also solid. Solid no need to write. Concentration of solid is equal to 1 divided by concentration of what? Fe2 plus. This idea you got means then remaining is easy. Now we can substitute the values. Guys, ready now? Okay, go. Yes. I hope you can see. Okay, ready? Oh, it's too heavy. Okay, anyhow I did it. Okay, you guys are there. That's why it's easy. Okay, every hurdles become easy. So E cell equal to E0 cell minus 0.0591 by n log zinc 2 plus by Fe2 plus. And one more thing I forgot to tell you. Here they given what? Again I am taking this one back. Here they given the EMF of the cell they given. Okay, what they given? The EMF of the cell they given 0.2905. That means this E cell they already given, that is 0.2905. Okay. So we have to find out what? E0 cell. We have to find out E0 cell minus 0.0591 by what is n? N is equal to, here how many electrons are participating? 2 electrons are participating. So divide by 2 into logarithm of what I can substitute? Concentration of zinc 2 plus. What's the concentration of zinc 2 plus? That is 0.1 divided by, what's the concentration of Fe2 plus, guys? Fe2 plus is 0.01. I can substitute 0.01. Now, okay. Now again I am going to take it to top. Okay. I hope you guys are ready. Come on. Yes. You can. Yes. Yeah. Here I am keeping. Okay. Here I am keeping. Is it okay now? Ready. Okay. So here I am going to solve it. Okay. So this is equal to 0.2905 equal to E0 cell. Okay. E0 cell minus this one 0.0591 by 2. That is nothing. That is 0.02905. Okay, 0.2905. Okay, into logarithm of 0.1 by 0.01. That is log 10. I am keeping that one as such. Okay, no problem. Nothing. Log 10 is how much? 1. Log 10 is 1. So I can eliminate this one. Then what is E0 cell? E0 cell equal to, I can take that one to here. So that become 0.2905 plus 0.02905. I have to add it. If I am adding, what I will get? You can see 0.2905 plus this one here 0.02, 0.02905. Okay, while I am adding, what I am getting here 5 is there, here also 5 is there, here 9 is there, here 9 plus 2 1 is there, here 3 is there, here 0. So 0.319. Okay, I am taking it is 0.32. So that is 0.32 volt. Okay, why I am taking 0.32 volt? Because in options you can see I am keeping this one here, they are giving 0.32, everywhere 0.32, that's why only I am taking 0.32 volt. Guys, okay now, ready? So E0 cell I got, what I got? E0 cell I got. What's the question? What's the question? They are asking about equilibrium constant. They are asking about equilibrium constant. So how I can find out equilibrium constant from E0 cell value? How I can find out? We know the idea. What's the idea? What's the idea? We know E0 cell equal to 0.0591 by 2 log Kc. So listen guys, what is E0 cell? E0 cell value they already given. What's the value they given? E0 cell equal to 0.32. So I can write 0.32 into equal to what is it? What's here? 0.0591 by 2. 0.0591 by 2. How much it is coming? 0.0591 by 2. We already discussed it. That is 0.02905. Okay, 0.02905 into log Kc. I am taking this one to left. So log Kc equal to, I can write log Kc equal to 0.32 by 0.02905. Then meaning Kc equal to, this log will go to right. That means anti-log. Anti-log means nothing. 10 to the power 0.32 divided by 0.02905. So we can check, is there any option like that? 10, okay, 10. We can check the options. Is there any option like that? We can check it. Listen to me carefully, guys. Listen to me very carefully. So yeah, there is an option is there. What's the option? While we are reading this one, you can see that's the option is there. 10 to the power 0.32 divided by 0.0295. Option B is the correct answer. What's the correct answer? Option B is the correct answer. You need some time, then you can solve it. Okay, this kind of long type questions also will be there. Some question you can quickly, within 1 second you can answer it. For 1 second answering and 1 second for bubbling. Okay, or else selection. So that means 2 seconds, 2 or 3 seconds, maximum 10 seconds. The remaining time you can use for this kind of long answer type questions. Okay, I hope this idea is easy. Ready now? Okay, if it's so, then we can move to the next question, guys. This is the next question. What's the question? Here is the question. How many moles of electrons are needed for the reduction of 20 ml of 0.5 molar solution of KMnO4 in acidic medium? We must have to remember, in acidic medium, KMnO4 usually used to become, that means MnO4 minus usually used to become Mn2 plus in acidic medium. That means the oxidation state of KMnO4, I mean manganese, is plus 7. That become 2 plus means 5 electrons are participating. Or else we can tell, if I am using 1 mole KMnO4 means here 5 mole electron will participate. How many mole electron will participate? 5 mole electron will participate. Now we can come to the question. What's the question? How many moles of electrons are needed for the reduction of 20 ml 0.5 molar solution of KMnO4? So we don't know how many moles. For that, to find out the number of moles only, they given 20 ml 0.5 molar. So we know molarity equal to, what's the formula for molarity? Number of moles divided by volume in liter. So that means number of moles divided by volume in milliliter into 1000. Okay. So this N means number of moles. Okay now. So what is number of moles? Number of moles equal to, how I can find out? Molarity into VML divided by 1000. Okay. Molarity into VML divided by 1000. So I can substitute the values. What are the values they given? What's the value for molarity they given? What's the value for volume in milliliter they given? We can check it. We can check it, guys. We can check it here. You can see what's the molarity they given? 0.5. What's the volume? 20. So I can substitute the value. Molarity equal to how much? Molarity equal to how much, guys? Molarity equal to 20, molarity equal to 20, molarity equal to 0.5, molarity equal to 0.5, okay, 0.5 into volume is equal to 20 divided by 1000. So I can cancel it. Which all are the values I can cancel is this 0, 0 I can cancel it, as well as 0.5 into 2 will cancel, 0.25 into, so 1 by 100 means 10 raised to minus 2 moles. 10 raised to minus 2 moles I have. I know that if I am using 1 mole camenophore means I need 5 mole electron. Then if I am using 10 raised to minus 2 mole camenophore means I need 5 into 10 raised to minus 2 mole electron. How many moles electron I need? 5 into 10 raised to minus 2 mole electron I need. So is there any option like that, guys? Yes. Option A is the correct answer. 5 into 10 raised to minus 2 mole electron I have. If I am using 2 mole camenophore means 2 into 5, 10 mole electron I need. So like that, that's the idea. Simple, direct. Okay. If it's so, then we can go to the next question, guys. This is the next question. What's the question? Here is the question. Standard reduction potential, that means SRP at 25 degrees Celsius of lithium plus bar lithium, barium 2 plus bar barium, Na plus bar Na, as well as Mg2 plus bar Mg are given. They given the value, okay, respectively. Which one of the following strongest oxidizing agent? What I told you, so many questions we did not, what I told you. If SRP value is very high, it will undergo reduction. It can act as what? Oxidizing agent. Tendency will be more. So we can check which one will have highest SRP value, which one will have highest SRP value out of these values, which is bigger value, This is minus 3.05, this is minus 2.9, this is minus 2.71, this is minus 2.37. So minus 2.37 is the bigger among this, because it is less only, this is bigger value, minus 2.37. Minus 2.37 is for what? Mg2 plus. So answer is Mg2 plus is the correct answer. That's the strongest oxidizing agent among the following. Is it okay now? Ready? So simple idea, direct idea only. We got the idea. If it's so, then we can go to the next question. This is the question. What's the question? How many gram of cobalt metal will be deposited when a solution of cobalt 2 chloride, okay, cobalt 2 chloride is electrolyzed with a current of 10 ampere for 109 minutes. This is actually directly related to our Faraday's law, Faraday's first law. They are asking about the how many grams means W only they are asking you to find out. What's the formula for finding W? Z into I into T. That idea you have to remember. Weight is equal to Z. Weight is equal to what? Z. That idea you have to remember. Weight is equal to Z. What is Z? Electrochemical equivalent. What is electrochemical equivalent? Atomic mass divided by N factor into 96,500 into I into T. What's the atomic mass of cobalt? That is 59. So I can substitute 59. What is N? N means N factor. For that N factor only they are telling the oxidation state. Cobalt is in 2 oxidation state. So its oxidation state is 2 into 96,500. Okay. If it is 3 means you have to put 3 there. 96,500 into I. What is I value? I value they given 10 ampere. I can put 10 here into T. T for 109 minute. 109 minute means 109 into 60. 109 into 60 second. Okay, this is minutes. You have to convert into second. 109 into 60. While you are solving this one, 0, 0, you can get cancelled. So 0, 0 will be get cancelled. Then while you can divide and substitute, what that time you will get approximately 19.99 you will get. That means 20 gram is the correct answer. Option B is the correct answer. I hope you guys got it. Purely mathematical. Directly equation is there means you must have to know how to substitute. Then you will get the answer. Ready now? Okay. Then we are going to the final question. This is the final question. What's the question? In She, the pH of acid solution should be. In She, the pH of acid solution should be. We know in She, the concentration of H plus how much? 1 molar. 1 molar. That idea we know. Then they are asking the pH of the acid. What is pH? pH is equal to minus log concentration of H plus. That means minus log 1. Log 1 is 0. So answer is 0 is the correct answer. That's all about the chapter electrochemistry. I hope you got all the ideas. All ideas are easy concepts only, but we explained very clearly, very easily, I hope so. Some techniques, tips and tricks also I taught support you. I hope you guys are happy. So we can see in the next chapter, guys. Up to that, thank you.